All right. So today we're talking about ellipses, section 10.3 of the textbook. It's the second of our conic sections. I kind of threw in another video about circles. Writing the equation for a circle in standard form is another learning target for this lesson. But you did that in geometry, so I just did like a little on its own video for that. So basically for an ellipse, we are going to get to know the key features, what an ellipse is, and then write the equation either from, write the standard form equation either from a different looking equation or like from the key features, similar to what we do with parabolas. So a circle is the set of all points that are equal distance from the center, right? They're all the radius away. If we take the center of a circle and we split it, and we got a center here, but then we have what are called the foci, and we can make an ellipse around that. That's not an exact ellipse, in the same way that's not an exact circle, but if this were an exact ellipse, what would hold true is every single point on this ellipse, for every single point on the ellipse, the distance from this focus to the point plus the distance from this focus to the point is going to be a constant. It'll always be the same value. So this plus this, let's say it's like 10. Well then, if I have a point over here, this value plus that value would be 10. This value plus that distance would be 10. Obviously, not every ellipse is going to have that sum be 10, but what's going to happen is for any ellipse, that sum of distance from one focus to a point plus distance from the other focus to a point is going to be constant. So once again, right, having a focus like this, kind of like with a parabola, you can use it to reflect things and then focus those reflections or those beams or whatever into a certain point. The focus point. All right, so now that we've got that idea, we're going to go over and we're going to talk about the general equation for an ellipse. And here we can have an ellipse that looks like this. And we can have an ellipse that looks like this. And obviously those are not perfect ellipses. But you get it. One has a horizontal major axis. So this is a horizontal major axis. Now the major axis is the longer of the two axes. So here, this would be the minor axis. The minor axis is the shorter one. So basically the major axis is the furthest away 2 points can be on the ellipse. The minor axis is as close as the 2 points can be on the ellipse. Now the equation for an ellipse with a horizontal major axis, so that's this one, is going to be x minus h squared plus y minus k squared divided by, so we're getting fractions here, this is going to be divided by a squared divided by b squared equals 1. So it's kind of similar to a circle, but what's happened is we have scaled basically the x and the y. Now here, this a value is that distance. It's half the major axis, or it's the distance from the center to what we call one of the vertices. So this is a vertex. And this also right here is a vertex. Each vertex is on the end of the major axis. The b value is this distance from the center to what we call the co-vertex. So that's a b. So here, there goes my pen cap. The minor axis has a length of b plus b, or 2b, and the major axis has a length of 2a, because a is the distance from the center to the vertex along the major axis. Now, in this case, in every case, the A value is always going to be bigger than the B value, and they're both going to be positive. So what happens is if we have a vertical major axis, like this example, so here this is our major axis again, major axis, here is vertical, then the equation is going to change slightly. We're still going to have, let's do a different color here, we're still going to have x minus h squared plus y minus k squared, where once again for both of these, the center is at h comma k. But here, since the major axis is vertical, it's going in the y direction. So the a squared is going to be under the y part, the b squared is going to be under the x part, and it's still going to equal 1. So in this case, with these values, with a major axis, with a vertical major axis, a is still the distance along the major axis from the center to the vertex, right? So that would also be a, vertex. And then b is the distance from the center to the co-vertices. Co-vertex, co-vertex. All right, so basically between these two, horizontal major axis, so like this, like a hamburger, that is when the larger number is dividing the x part, basically. And one that looks like this, so more like a sideways hamburger, sorry, right, that's where the larger number, the a value, is dividing the y part, so it's a vertical major axis. So there's some more information to kind of throw down about these. Let's see if I can use one of these pens to make it work. Let's try red. So once again, oh, sorry, the foci. The foci are the focuses. So the foci, and foci is plural for focuses, for more than one focus. So focus, focus. But we're saying more than one, so it's foci, foci, foci. So the foci always lie on the major axis, and they're the distance c away from the center along the major axis. So the foci are c away from the center on the major axis. And what is the c value? It's using this rule where we have c squared equals a squared minus b squared. So it's kind of like the Pythagorean theorem, but with a subtraction instead of an addition. If you want a proof of it, you can Google it. Basically, it's just a bunch of stuff with triangles and a bunch of Pythagorean theorem things to get there. But c is always going to be greater than 0 because the a value is always going to be bigger than the b value. So the a squared minus b squared is going to be your c squared. Then you'll square root it and you'll get that distance. This will often be a square root, or it'll be like a not so nice whole number. It won't be a whole number, usually. Unless you're given the focus. Like if you're given A and B, more often than not, C is going to have a decimal estimate, which you would just use as a square root answer. Okay, so what else do we got here? Right, vertices are on the major axis. Co-vertices are on the minor axis. So co-vertices, co-vertices, vertices, vertices. It depends, right, if it is a vertical major axis or horizontal major axis, where you put those. The foci are always on the major axis. When it's horizontal, the bigger number is dividing the x. When it is vertical, the bigger number is dividing the y part. Now, just a couple more things. We have what's called the eccentricity. Let's use a different pen. Let's mix up the colors. Why? Because we can. Or I guess because I can. You're just watching, sorry. Be better if, we were in class, but it's not what it is. So the eccentricity is this lowercase e, which, yes, we also use as a number e, but here with ellipses, when we're talking about eccentricity, if you see this e, that's going to stand for eccentricity. The eccentricity tells you basically how circular or flat the shape is. So the eccentricity is this ratio of c over a, where c, remember, is the distance from the center to the focus, and a is the distance from the center to the vertex. So if e is close to 1, then basically that means c and a are close to the same number. So like number divided by itself would be about 1, which would mean these foci are getting closer and closer to the vertices, which would be expanding it out and be flattening it. This is going to mean it's going to be flat. It's going to be a flat ellipse. It's going to be more like a hot dog than like a circle. If e is close to 0, in other words, the foci are the c value. If the c value is small divided by the a value, so small divided by big is going to be small. So as the foci come closer to the center, the eccentricity gets closer to 0, and it's more like a circle. More like a circle. Okay. So I know I just threw a lot of info at you. Sorry, I'm checking my notes to make sure I didn't leave anything out. Looks good. Right, you can always go back, look at the notes I gave you. You can Google this sort of thing as well to get some of the info. Let's jump in. We're going to do 2 examples on this video, and then I'll throw out 2 more examples if you need extra help. Okay, so let's go ahead and start our first example of writing the equation from some given information and putting it in standard form and then finding the rest of the information. Here we go. Well, not quite. We're not there yet, but we're getting there. All right. Let's dry it off. Okay. So we're looking at an ellipse that has foci at 0, 1 and at 4, 1. Yep. And then the major axis length is 6. And what we want is we want a graph, we want an equation, we want the center, we want the minor axis, length, and we want the vertices and the co-vertices. Vertices, co-vertices. Want all that information. Oh, and the eccentricity. There we go. Right, lots of stuff. These problems are a little bit longer than the parabola ones. So let's just dive right in. We're going to start by just putting this information on the graph. So I know 4, 1. One, 2, 3, 4, 1, that's one focus. And then 0, 1 is another focus. So those are my foci. And I know the major axis has a length of 6. So if the major axis length is 6, that means A equals 3. Or the distance from the center to the outside is 3. So if I've got 6, then it's 3 on this side, 3 on that side. Okay. Now, from the foci, I can find my center because the center is, well, in the center of the foci. So I go here, I'm like, all right, this is at 0, this is at 4, they both have the same y value. What's halfway between 0 and 4? 2, right? 2. So the center Where are we at? Center is at 2, 1. Now I can find my vertices because I know A equals 3. I'm going to go 3 to the right to get a vertex and 3 to the left. 1, 2, 3 to the left to get another vertex. So my vertices now I can say, where are we at? There we are at 5, 1 and at -1, 1. Cool. We're working now. Yes, we are. So we also want to find, we need to know our b value for our equation, because remember our equation is, well, one more thing. This is a horizontal major axis. We know it's a horizontal major axis because the foci always lie on the major axis. So if your foci are lined up this way, it's horizontal. If your foci are lined up this way, it's a vertical major axis. So here we've got a horizontal major axis, which means we're going to have the x minus h squared over a squared plus y minus k squared over b squared equals 1. In other words, the a squared, in this case that would be 9, is going to be dividing by the x minus h. So for our equation, we can go x minus h squared, so x minus 2 squared over a squared, which is going to be 9, plus y minus 1 squared, because 1 is the y number on the center, divided by b squared equals 1. We've got to figure out what b is to finish off our equation. So we have to remember the relationship between a, b, and c, which is c squared equals a squared minus b squared. This is for an ellipse. This is not Pythagorean theorem. This is the ellipse formula. So c is the distance from the center to the focus, so c equals 2. So here I get 2 squared, which is 4. A is 3, so I have 9, and then minus b squared. We can do a little bit of algebra, add a b squared, subtract a 4 over, basically get b squared equals 5, because 9 minus 4 is 5. Square root the b squared to get b equals square root of 5. Now, in the equation, we're just going to put b squared down here, right there. So the square root of 5 squared, or b squared, is just equal to 5. So just a 5 goes down here. Boom, we got our equation. Wonderful. Now what we need to do is finish our graph and then find the rest of this information. So to finish our graph, what we're going to do is we're going to find our co-vertices. Our co-vertices are this distance, b, or root 5, away from the center. And because our major axis is horizontal, that means our minor axis is going to be vertical. So what I have to do is I have to add approximately, for the graph, approximately square root of 5. Square root of 5 is a little bit bigger than 2. So I'm going to go just a little bit more than 2 above, just a little bit more than 2 below, and that's going to be a co-vertex and a co-vertex for the graph. Now it's not a perfect graph, obviously, because I drew it on this, but I can see, yeah, it doesn't quite look like an ellipse, it looks more like an egg, but I can see like where each point was supposed to go. Now, where exactly are these co-vertices? Well, the x number is the same as the center. So for the co-vertices, we're going to use the x number of the center, and then we're going to use the y number of the center, and we're just going to add the b value to it. So we go plus square root of 5, and then I'm going to use the y value again, minus the square root of 5. And because we're using square root of 5, we can just leave it like that. 1 plus root 5, 1 minus root 5. And please, just leave your answers like that. That's the exact way when you get to college. Your teachers are going to want to see those square root numbers in there instead of decimal expansions. If you were actually graphing it, specifically, you would, well, do the decimals for that. Oh, it's Emma Bear. Come here, Emma. Emma wants to say hello. Hello, Emma. Yep, that's my pre-calc class. They can see you now. All right, be good. Okay, sorry for that. Major axis length. The length of the major axis is, well, this was square root of 5, that was square root of 5, so it's 2 square roots of 5 because it's 2b. So this is 2 square roots of 5. And last thing is our eccentricity. Remember, eccentricity, E equals C over A. Well, C is 2, A is 3, right? C equals 2, so it's just 2/3. And that's it. Okay, hopefully you were able to follow that. Let's go ahead and move on to our next example. And right, we got our complete graph, so that's wonderful. All right, so next example, what we're doing is we're taking an equation that's not written in this form and rewriting it in standard form, and then finding all this information, sketching a graph. So, I'm gonna erase this. See you later. But you're safe forever on a video, so it's okay to get erased. There we go. Ugh. It's not quite as clean as a whiteboard at school, but this thing works. Okay. Here we go. Let's dry it off. All right. Okay. Let's try this pink pen. So we've got this equation, which is x squared plus 4y squared plus 6x minus 8y plus 9 equals 0. What we want to do is we want to write the equation in standard form. So we're going to have the equation. And then we want all the other information, right? Like the center, the vertices, the co-vertices. We want the foci. Where are those foci? We want the major axis length. I can still use pink. Oh, yeah. So the major axis length, the minor axis length. All right, lots of info. And the eccentricity. Okay, let's get to work here. So if we're actually working on rewriting the equation in standard form, in that form that we can pull all this information out of, what we're going to do is we're basically going to complete the square twice. We're going to break it up so we got x's, y's, numbers on the other side. It's a little bit more complicated than the circle or the parabola, but it's still the same idea for the most part. So I'm going to take the x's, so x squared plus 6x plus blank to complete that square there. And then I'm going to go plus 4y squared minus 8y plus blank. Hold on to that though, we're not putting in the blanks yet. And then I'm going to move this 9 over to make it equals -9, and then we'll have a plus blank plus blank. All right, so here I can complete the square on this one. But here I've got a 4y squared. So what we want is just a y squared. So I'm going to rewrite this, and you could have done this step here as x squared plus 6x plus blank, and then plus 4 times. I'm going to factor this 4 out. So divide by the 4, divide by the 4, so I get y squared minus 2y plus blank, and then we'll have the equals -9 plus blank plus blank. All right, so here I'm going to take this. So now I've got it, regular x squared, regular y squared. I need to find out what goes in those blanks and then what goes over here, so that we can then have 2 complete squares and, well, more steps. So take the 6, divide it by 2, divide by 2, get a 3, square the 3 for a 9. So I need to add 9 over here as well. So add 9, add 9. Here, I'm going to take this negative 2, divide it by 2. Divide it by 2. Sorry. Negative 2 divided by 2 gives us negative 1, but when we square that, we get a positive 1. But here, we are actually adding 4 ones because there's a 4 that we factored out. When I add 1 inside the parentheses, I'm making this side of the equation bigger by 4. So I need to add 4 to this side of the equation. That's the part that's a little bit trickier that you just have to kind of remember that anytime you're completing the square when you've factored something out, whatever number goes inside those parentheses in that group, you have to take into account you've got, well, however many of those that you're actually adding to this side of the equation. All right, so now we're going to simplify this. Here, let's grab a different pen. Let's go orange. We have x plus 3 squared, because it's half of that, or the square root of that, plus 4 times y minus 1 squared, because it's a minus, equals 4. So we're close to what we want, but we're not quite there. Remember, we wanted like this divided by something plus this divided by something equals 1. So what I need to do now is I need to make that into a 1. And we're going to do that by using division. So I'm going to take this 4, divide it by 4, divide this by 4, divide that by 4. So basically I'm going to divide both sides of the equation by 4. And that's going to give me x plus 3 squared over 4 plus y minus 1 squared over 4 divided by 4 gives me 1 equals 1. And boom, that's our standard form equation. So from that, we can find the rest of this information. So let's just go about doing that. While we're doing that, we're going to piece together the graph as well. So the center is going to be at, well, it's x minus h and then y minus k. So center here is going to be at negative 3, comma 1. So when we go over to our graph, let's use this pink color here. So negative 3 for my x, 1 for my y, 1, 2, 3, 1. There's my center. Now I know this is going to have a horizontal major axis because the denominator on the x term, or on the x part, is larger than the denominator on the y term. So this tells me that it has a horizontal major axis. If this number was, if it was a 4 here and a 1 there, it would have a vertical major axis. Okay, so now we got our center. We want to find our vertices and our co-vertices. Remember, our vertices are going to be A away from the center. Now here, 4, this 4 is our A squared. So let's do it different. Let's go here. So 4 equals A squared. That means A equals 2. So the vertices are going to be 2 away from the center in the x direction. The x direction because that A squared is under the x, because that's larger than the 1. So I'm going to go 2 to the right and 2 to the left. So we've got vertex, vertex. So I have one vertex at negative 1, comma 1, and I have one vertex at negative 5, comma 1. Now for my co-vertices come from, or sorry, the distance is b away. This 1 is b squared, so that means b equals 1. So I go 1 in the minor axis direction. In this case, it'll be vertical. If, remember, if like this was larger, it would be, then y would be your major axis. But because the 1 is smaller, the y direction, the vertical is our minor axis. So I go up 1 to get a co-vertex, and I go down 1 to get another co-vertex. That is enough for the graph here. Sorry, to put in the shape of the ellipse. It's not enough for like the complete graph. I want more information than that. Specifically, I want the foci on the graph as well. But let's go ahead and put in the values. Sorry, not the values, the coordinates for these co-vertices. So the co-vertices, one of them is at negative 3 comma 0, and the other one is at negative 3 comma 2. So basically just adding and subtracting 1 from the y value here. All right, for the foci are going to lie on this major axis right there, and they're going to be c away from the center on that major axis. So what we have to do now is we have to remember that c squared equals a squared minus b squared for an ellipse. We know a squared and b squared, so c squared equals 4 minus 1, c squared equals 3, so c is the square root of 3. So basically I need to go root 3 to the right and left of the center. So let's go ahead and do that. Root 3 is like what? 1 point, I'm just going to double check it. I think it's 1.7. So square root of 3 is, yeah, it's 1.732. So about 1 3/4. So a little less than 2. So that means I get a focus here, and I get a focus there. So I'm going to say foci. You can draw little arrows to them. Foci there, and they're right and left root 3. So when I'm writing my answer for that, for the foci, I'm going to say x number of the center plus square root of 3, comma 1, and number from the center minus square root of 3, comma 1. Basically, the y value is the same, but we are adding root 3 and we're subtracting root 3 from the center to find those foci. And here we're doing it to the x numbers. If this was a vertical major axis, then we would add or subtract it from the y value of the center. All right, so we're almost done with the problem. The graph is good. Looks good. What we need to do now is find major axis length, minor axis length, and then state the eccentricity. So the major axis length is this distance here. Remember, this is always 2 times that distance. So it's basically just 4, because 2 times 2 is 4. So major axis length is 4. Minor axis length is from covertex to covertex, which is 2, because it's twice the b value, which is 2. Last thing is the eccentricity. Remember, E equals C over A. So here the eccentricity is root 3 over 2, or about 0.86 something. So it's a fairly flat ellipse. Okay, and that's it for this video. I'll do another video with a couple more examples that you can look over